Welcome back. This is the second part of data analysis for solving technical problems. In this part, we will cover the final three phases of analyzing data by using the CRISP-DM standard: modeling, evaluation, and deployment. Let's first recall all the 6 phases of the CRISP-DM standard process again. We already covered the first 3 in the previous module, Data Analysis for Solving Technical Problems, Part 1. So, we will now focus our attention to the final 3 phases and start with the modeling phase. With clean data at hand, various modeling techniques, often called machine learning algorithms, are applied. Each method may require specific data formats, so it's not uncommon to loop back to the data preparation phase. Key tasks in this phase include selecting the appropriate modeling technique, designing tests, building the model, assessing the model. Before proceeding to deployment, the model's performance is thoroughly evaluated. This ensures that it meets the business objectives set in the first phase. Key tasks in this phase include evaluating results, reviewing the process, determining the next steps. The final phase involves deploying the model into a real-world environment. This can be as simple as generating a report or as complex as implementing a repeatable data mining process. Key tasks here include planning deployment, monitoring and maintenance, reviewing the project, finalizing the project. Now, let's dig deeper into each of these 3 phases. The modeling phase. This is the phase where all the magic happens. This is the phase where you need to decide which machine learning algorithm to use. Things to consider in this phase. Are you doing supervised learning or unsupervised learning? What type is your problem? Regression, classification? Will we choose a classification algorithm or rather opt for a regression one? This depends on the type of the target variable in our data. A nominal target variable means we will choose a classification algorithm. A numeric target variable means a regression algorithm is more suitable. Having a target variable for which we already know some historical values means we can use that variable to supervise our learning process. This is where the term supervised learning originates from. Examples of supervised learning algorithms include, for regression, SVM, gradient boosting regressor, regression trees, and similar. For classification, logistic regression, decision trees, random forest, and similar. We not always have the luxury of having a target variable with known values. In such cases, we have to resort to unsupervised machine learning algorithms. Examples of such algorithms include k-means clustering, a priori, FP growth, self-organizing maps or SOMs, and similar. In this phase, we shall look at 2 aspects of the model's quality, from the model perspective and from the perspective of business objectives. From the model's perspective, we can use accuracy metrics such as mean squared error, confusion matrices, etc. If the model accuracy is bad, you might need to have a look at your data preparation phase or data modeling phase again. From the business objectives perspective, you evaluate your model by checking whether it helps meet the business success criteria that you defined in the business understanding phase and whether there is any room for improvement. Here, we use the already preprocessed data from the initial phases of CRISP-DM for our winery business scenario to illustrate the application of the modeling, evaluation, and deployment phases on this data. This is clearly a supervised type of problem, since we already have a target variable, namely the quality rating of wines. Since the quality rating is a value from 1 to 10, 1 denoting a bad wine and 10 denoting an excellent wine, we could use a regression machine learning algorithm to analyze this data, let's say linear regression. If, on the other hand, we binarize the target variable, we can also use any of the classification algorithms, XGBoost for starters. Well, in the modeling phase, we try and get the model that produces the best output according to standard model evaluation techniques, confusion matrix or accuracy. This evaluation stage is more focused on the business perspective. A good recommendation would be to suggest the binary classification model as it has a high recall. This means Of all the 7 plus rated wines, it correctly identifies the most, with a slightly higher false positive rate. If we assume there is a step after the prediction results are obtained to have experts within the winery assess the identified high-quality wine, then this gives us the best chance to not miss the best candidates. The deployment for this could be as simple as giving the chosen model to the winery and educating them on how to input the variables of the wine they want to assess and get a prediction of quality, so they can self-serve the analysis. Sometimes deploying the model is not the end of data analysis. New insights may lead to the redefinition of business objectives, and the whole 6-phase PRISM cycle can repeat. As this model is concerned, we did reach the end of it and will not recycle. Thank you for listening.